Hello, and welcome to my channel. Today we will see some amazing facts and mysteries behind dark matter, so without any delay, let's get started. Dark matter, a component of the universe whose presence is discerned from its gravitational attraction rather than its luminosity. Originally known as the missing mass, dark matter's existence was first inferred by Swiss-American astronomer Fritz Zwicky, who in 1933 discovered that the mass of all the stars in the Coma cluster of galaxies provided only about 1% of the mass needed to keep the galaxies from escaping the cluster's gravitational pull. The reality of this missing mass remained in question for decades, until the 1970s, when American astronomers Vera Rubin and W. Kent Ford confirmed its existence, by the observation of a similar phenomenon. The mass of the stars visible within a typical galaxy is only about 10% of that required to keep those stars orbiting the galaxy center. Dark matter is a hypothetical form of matter thought to account for approximately 85% of the matter in the universe. Its presence is implied in a variety of astrophysical observations, including gravitational effects that cannot be explained by accepted theories of gravity unless more matter is present than can be seen. For this reason, most experts think that dark matter is abundant in the universe and that it has had a strong influence on its structure and evolution. Dark matter is called dark because it does not appear to interact with the electromagnetic field, which means it does not absorb, reflect or emit electromagnetic radiation, and is therefore difficult to detect. Observations show that there is far too little visible matter in the universe to make up the 27% required by the observations. Second, it is not in the form of dark clouds of normal matter made up of particles called baryons. We know this because we would be able to detect baryonic clouds by their absorption of radiation passing through them. Third, dark matter is not antimatter, because we do not see the unique gamma rays that are produced when antimatter annihilates with matter. Finally, we can rule out large galaxy-sized black holes on the basis of how many gravitational lenses we see. Gravitational lensing is the distortion of the appearance of an object by a source of gravity between it and the observer. Gravitational lensing occurs when massive objects bend the paths of light beams passing nearby. Primary evidence for dark matter comes from calculations showing that many galaxies would fly apart, or that they would not have formed or would not move as they do, if they did not contain a large amount of unseen matter. Other lines of evidence include observations in gravitational lensing for, and in the cosmic microwave background, along with astronomical observations of the observable universe's current structure, the formation and evolution of galaxies, mass location during galactic collisions, and the motion of Genderd lambda CDM model of cosmology. The total mass energy of the universe contains 5% ordinary matter and energy, 27% dark matter and 68% of a form of energy known as dark energy. Thus, dark matter constitutes 85% of total mass, while dark energy plus dark matter constitute 95% of total mass energy content. Because dark matter has not yet been observed directly, if it exists, it must barely interact with ordinary baryonic matter and radiation, except through gravity. Most dark matter is thought to be non-baryonic in nature. It may be composed of some as yet undiscovered subatomic particles. The primary candidate for dark matter is some new kind of elementary particle that has not yet been discovered, in particular, weakly interacting massive particles, WIMPs. Many experiments to directly detect and study dark matter particles are being actively undertaken, but none have yet succeeded. One idea is that it could contain supersymmetric particles, hypothesized particles that are partners to those already known in the Standard Model. Experiments at the Large Hadron Collider, LHC, may provide more direct clues about dark matter. Many theories say that dark matter particles would be light enough to be produced at the LHC. If they were created at the LHC, they would escape through the detectors unnoticed. However, they would carry away energy and momentum, so physicists could infer their existence from the amount of energy and momentum missing after a collision. Dark matter candidates arise frequently in theories that suggest physics beyond the Standard Model, such as supersymmetry and extra dimensions. One theory suggests the existence of a hidden valley, a parallel world made of dark matter having very little in common with matter we know. If one of these theories proved to be true, it could help scientists gain a better understanding of the composition of our universe and, in particular, how galaxies hold together. As an alternative to dark matter, modifications to gravity have been proposed to explain the apparent presence of missing matter. These modifications suggest that the attractive force exerted by ordinary matter may be enhanced in conditions that occur only on galactic scales. However, most of the proposals are unsatisfactory on theoretical grounds as they provide little or no explanation for the modification of gravity. These theories are also unable to explain the observations of dark matter physically separated from ordinary matter in the bullet cluster. This separation demonstrates that dark matter is a physical reality and is distinguishable from ordinary matter. So friends, this is it for now. If you liked the video, then don't forget to like and subscribe and share it with your friends. We'll try our best to bring you such amazing facts about the universe. Till then, take care and goodbye.